Okay, Mike Adams here. Welcome to this special report about a new breakthrough in sodium-sulfur battery chemistry and battery architecture that has huge implications for everything from off-grid living to electric vehicles to robots to grid shifting, power storage technology, and also it impacts geopolitics. It impacts the world, the control over routes and resources, and control over commodities. Why? Well, because this battery technology doesn't need lithium. And so if you think about it, one of the big reasons that there's this push to control routes and to control mines in Africa, or even the push for territory like Greenland and other places, is because, well, people want access to lithium. Lithium-ion technology is currently the mainstream battery tech for energy storage, and especially for mobile devices or edge devices. That would be things like electric vehicles. And yet lithium-ion relies on this difficult-to-acquire element, lithium, which only comes from certain places and requires a lot of water for processing, and it's difficult to mine, in certain regions, etc. So this announcement about sodium-sulfur battery technology is a very big deal. So sodium-sulfur battery chemistry has been around a long time, but it sucked until just now. So of course this breakthrough comes out of China, which has the most engineers now of any country in the world in terms of the number of engineers graduating from university programs every year. So this comes from the Jiaotong University in Shanghai. And their researchers have been able to use a new chemistry called the sodium-sulfur redox chemistry that allowed them to achieve an energy density of an astonishing over 2,000 watt-hours per kilogram. So remember that, of course, kilogram is a measure of mass. Watt-hours is a measure of total energy storage. A watt-hour is 1 watt emitted over 1 hour. So 2,000 watt-hours means 2 kilowatt-hours. That would be, of course, 2 kilowatts over 1 hour. And this is stored in 1 kilogram of the battery. Now, when I saw this number 2,000, I was almost in disbelief for a number of reasons. Because remember, I've talked about this new supposed battery from Donut Lab out of Estonia that was unveiled at the CES show just recently here in 2026. And the Donut Lab battery claims an energy density of 400 watt-hours per kilogram. Now, 400 watt-hours per kilogram is considered extremely good. Even for lithium batteries, that's considered very good. A lot of lithium batteries on the market today are only in the 250 watt-hours per kilogram range. So this announcement of a sodium-sulfur technology at over 2,000 watt-hours per kilogram, this is literally 10 times the energy density of many lithium-ion batteries that exist right now. And for others, for the high-end batteries, it's still 5 times or more. So this is a very big deal. So why is all this a big deal? Because, of course, sodium and sulfur are two elements that are abundantly available. Sodium is available all across North America. We don't need to go overseas to get sodium. I mean, we just get it out of the ground. It's everywhere in North America. Lots and lots of like salt brine mines or old mines or different ways to extract sodium in abundance out of the ground. So sodium, which can also be extracted from, by the way, seawater brine as a byproduct of desalination of ocean water. So when you take ocean water in to a desalination plant and you pull the fresh water out of it, you get left with this salty brine, which is just concentrated seawater that's largely sodium and magnesium with, sodium chloride and magnesium, and then a lot of other trace elements in there as well. It's got all the elements in there, just at much smaller amounts. So anyway, there's plenty of sodium to go around. That's easy to find. You don't need a deep water navy to go around the world to bomb countries and threaten countries in order to get sodium. Sodium is in your backyard, right here in North America. Sulfur is the same thing. Sulfur is a waste product of industry. I mean, sulfur is a waste product of coal and coal-burning power plants. It's a waste product of like petroleum refining. Sulfur, they're trying to get rid of sulfur, So there's plenty of sulfur to go around. And then you combine sodium with sulfur with this new chemistry, this 4+ redox chemistry. That's it's a highly energetic, high potential state of how sulfur can be configured chemically. Then that creates a non-flammable electrolyte. So it doesn't burn, it doesn't have runaway thermal problems like lithium. It's not going to self-ignite the battery. But the storage density is extremely high. It's incredibly safe because, salt doesn't burn very easily and sulfur doesn't burn very easily. I mean, sulfur can be used to put out fires in some cases. Sulfur is used to clean up acid spills. In the lab, we have sulfur in the lab, to neutralize acid spills of nitric acid, things like that. So sodium and sulfur are incredibly safe, high energy density, easily available, using materials that are not coming from conflict areas. Wars, Ukraine or Greenland or Africa or Central South America, whatever the case may be. So these minerals are easy to find, and the battery chemistry is breakthrough chemistry. So to talk about the actual battery construction here for a second, for those of you who want to geek out with me on this. So from the article that's reporting on this, so they switched to a sulfur 4+ redox chemistry. So in other words, there are 4 valence electrons per sulfur atom. And they were able to then produce a voltage of 3.6 volts, which has never been achieved before in sodium-sulfur batteries. And this is necessary. 3.6 volts makes it usable in EVs and robots and so on. And you stack these batteries. You stack them, both serial and parallel connections to increase the voltage and increase the depth of the charge or the total storage. And but you got to have 3.6 volts to make it work. But here's what else they're saying. They have eliminated the anode somehow, which I don't even understand how that is possible. They say these are anode-free batteries, which, I thought, is this an April Fool's joke? Because we've had a lot of weird announcements about battery technology lately, and some of it doesn't seem real. But anyway, they're claiming that they don't need the anode anymore. They say that there's an aluminum foil anode current collector. Well, I don't know. It sounds like an anode, but whatever. That's what they're saying. So aluminum is necessary in this, but aluminum is very abundant. Aluminum is very cheap. They need an S8 cathode, a sodium dicyanamide in a non-flammable chloroaluminate electrolyte separated with a glass fiber. Okay, so for those of you who want to cook this up in your own kitchen, that's the secret sauce. Apparently, just be careful. Some of this stuff may be toxic. Okay, the diacetamide anion in the electrolyte unlocks the chemistry at the cathode while improving the reversibility of sodium plating and stripping at the anode, they say. I thought they said they don't have an anode. Well, anyway, they get over 1,200 milliamp hours per gram, and the energy density that I mentioned before, over 2,000 watt hours per kilogram. And the cost, this is another huge factor here. So let me take a tangent here for a second. You may recall that I've said everybody should use the metric system. And that's what I've used in my lab all these years that I've been, running the lab, mass spectrometry and ICP-MS and chromatography and everything. You can't work in a lab unless you use the metric system. the metric system is the only system that makes any sense. Now, if you want to get into anything that talks about batteries, energy density, battery storage, whatever, EVs, you have to use metric units. So I don't even know what the units could even be in the imperial system for a lot of these things. Like, what would you say? Like, watt hours per ounce? It's like 2 teaspoons per sodium cup per amperage quarts or something. I mean, it doesn't even make any, the imperial system doesn't work here. So we're always going to use metric to talk about energy density, because the metric system, again, is the only system that makes any sense. Okay. So it's also critical because I'm going to be talking about this battery chemistry a lot this year and writing a lot of articles about, in fact, I just wrote an article about this. So you'll see that on Natural News right now. And the reason that I'm so interested in battery chemistry technology is because it enables off-grid, decentralized living. The only thing that's missing right now from the technology stack to live completely off-grid, to disconnect from the grid, the only thing that's missing is good batteries. We've got the solar panels, and they're not even that expensive anymore. We've got sunlight, that's free until Trump slaps a tariff on it or something. 10% tariff on the sun. We've got inverters, we've got charge controllers, all that stuff. Okay, what we need is batteries that don't suck. And right now, the lithium-ion batteries that are out there in the marketplace, they suck. They all suck, and lead acid is the worst. And that tech is like thousands of years old. Don't even get me started on that. So I've been talking about sodium-ion batteries for quite some time, thinking that this could be a very good off-grid energy storage system. And then that's why I'm covering this sodium-sulfur technology. But there are clearly other chemistries, and mega corporations like Samsung and Toyota and all these car companies and tech companies are working on this. We're talking about maybe 10,000 engineers globally are trying to build breakthrough battery tech. And some of them claim they've done so. Even like this team right here. This is a breakthrough. If this turns out to be, commercializable in at scale, this is a breakthrough. There are other breakthroughs that are claimed by these other companies, but sooner or later, probably this year, one of these is going to be the holy grail of battery chemistry, or maybe this year or next year. It's going to happen soon, and it's going to change everything. When that happens, you're going to see lots of people going fully off-grid. You're going to see EVs having ranges that were unthinkable, like 1,000 kilometers. You're going to see robots finally able to work, let's say, an 8-hour day without needing to be recharged. You're going to see drones that will have a 1-hour flight time, instead of the current 20 minutes or whatever it is. This is going to change everything. Laptop computers, mobile phones, every electronic device is going to benefit from this battery technology, and it's going to change the way we live. It's going to enable us to live more off-grid, more decentralized. So that's why this really, really matters. It's also going to lower the end cost of electricity to the consumer. Because think about it. If you have, sorry about this tangent, but let me back up. The sun clearly produces all the energy that we need on this planet many times over. And Elon Musk loves to talk about this. The sun gives us all the energy we need if we just collect it. And we only need a very small percentage of Earth's surface, if it's wired up with solar panels, to be able to power the entire human economy as we know it, other than things like tractors that need, big bad diesel engines or barges or ships on the sea. Right now they need much higher fuel energy density with diesel or bunker fuel, things like that. We'll get to that later. But for most of society, running your home, charging your car, air conditioning, blenders, hair dryers, powering your office, all that stuff, that can all be done with sunlight. Why? because that's all fusion energy captured by solar panels. So the sun is a giant fusion ball in the sky. It's massive. Let me put it this way. The sun is, I think it's 99.9%, or maybe it's 99.8% of the total mass of the entire solar system. In other words, the sun is so large, it's got so much mass in it, that even Jupiter or Saturn would be a rounding error compared to the mass of the sun. And Earth is a tiny little, is incomparable. Earth is tiny compared to the sun. So the sun has all this mass, and it's converting that mass into energy for free, obviously, and all we have to do is tap into it. And that's solar. But the problem with solar this entire time has been, how do you store it? Because there's this thing called night, or rain, or clouds, etc., or just seasonal variation of sunlight. And so storing sunlight energy has always been the challenge. And up until now, battery technology has really sucked, and that's why we haven't been able to make solar power really, really affordable, because we can't store it. But these breakthrough battery technologies change everything about that. And if you think about the data centers right now, so many AI data centers being built across the United States and around the world, and they don't have enough power. Some of them are dark in the U.S. because there's just not enough power to run the data centers. So, these companies like Microsoft did a deal with a nuclear power company. We're gonna buy everything coming out of this nuke plant. That's desperation right there, but they've done it. You've got companies, especially on the eastern power grid in the United States, the grid will tell companies, if you build a data center here, you have to bring your own power. And so the data center companies are out there shopping for gas turbines, like a 300 megawatt gas turbine, which is kind of on the smaller side. And then the gas turbines are all sold out everywhere. And of course, the U.S. sanctioned Russia, which makes arguably the best gas turbines in the world, and we can't buy them because of the economic sanctions. And so we have to get gas turbines made somewhere else, and there's a wait time anywhere from now 5 to 10 years. So you can't power data centers with gas turbines. You can't power them with nuclear power because the nuclear power takes 14, 15 to even 20 years to come online. And you can't power them with coal-fired power plants because the environmentalists lose their minds over coal. So how do you power data centers? You do it with solar. You can build that up now. You can just buy a boatload of solar panels and you can cover farm fields. This is what they're doing. And you can have solar power right next door. The problem is night, clouds, rain. How do you do it? You need battery tech. You need battery technology with high energy storage density and also low materials cost that can scale and that won't catch on fire and blow up your whole freaking data center. That's what we're talking about. Sodium-ion battery chemistry and sodium-sulfur battery chemistry. That's why this matters. Because the race to AI is a race to superintelligence. China's going to win that race unless something dramatically changes. China's ahead of the game. China's got a massive amount of power. They have their power grid is more than twice the aggregate annual output of the United States power grid. It's not even close. And China is adding more power far more rapidly than the United States is. So China will be able to power all its data centers. The U.S. won't, unless we have battery technology that can grid shift. And the way that works then, let's say you have a data center and you need a gigawatt of power 24/7. So in one day, how many gigawatt hours of power would you need? The answer would be 24, because there's 24 hours in a day, right? I'm just reviewing the units here together. So you need 24 gigawatt hours of power every single day. So what do? You build a solar farm that can produce about 75 gigawatt hours. You go about triple. These are rough numbers. You go about triple because the sun is not always shining, right? And there's, the sun is not always at the right angle. So you only get peak solar production for about 2 hours of the day. And even seasonally, that varies based on the axial tilt of Earth relative to the orbital plane of the sun. Also, that's called winter and summer. There's an axial tilt. The path that the sun takes through the sky is lower in the winter and higher, more overhead in the summer. That affects everything as well. So anyway, you're going to build about 3 times what you need, maybe 4 times. So you could, let me just say it this way. If you needed 24 gigawatt hours every day, you might build a solar farm of 100 gigawatt hours, because you got to produce a lot of excess power. And where are you going to put it? You have to store it in something that's cheap and scalable and safe and has high energy density. Once you can do that, then you can power data centers with the sun. You can power factories with the sun. You just need a lot of land. Guess what? North America has a lot of land. And a lot of it's unusable land, like desert land, I don't recommend that we put solar panels all across all these usable farms. We need to grow food for humans, assuming there's any left after Skynet. But or after the globalist depopulation agenda, let's assume there's some humans left. They're going to need to grow some food. So I say put the solar panels out in the deserts. Unfortunately, the deserts don't happen to be right next to where the data centers are, so there's a transmission challenge, but that's beyond the scope of this conversation. Anyway, battery technology makes it all possible. Battery technology is the missing link that, if it's solved, it will unleash truly economic abundance in America. Truly. Energy would get cheaper instead of more expensive, by far. And if energy gets cheaper, do you know that makes AI inference cheaper? Because the number one cost of AI inference, especially for open source models like DeepSeek from China or Qwen, the number one cost is electricity. Electricity costs go down, AI goes down, AI costs go down, and then cognition becomes more readily available and cheaper and more widespread. And that has huge benefits for society. So you see how all this is connected? We need better battery technology to unleash all these other technologies and to unleash economic abundance. And then when you get to the point where robots can actually grow food, and that's coming, we're talking about robot farmers, It's a few years away, but it's coming. I can't wait. I'm really excited about my weed-pulling robot concept. When you have cheap electricity, then you have cheap robot labor growing food, which results in what? Anyone? Bueller? Cheap food. That's right. Cheap food in the grocery store. So whereas right now, food is suffering massive inflation because of all the money printing, obviously, the fiat currency nonsense. So you have food inflation like crazy. But if you were to have great battery technology combined with AI robotics, where you can run a robot for, I don't know, $1 an hour or $2 an hour, I don't know, something in that range, guess what the cost of tomatoes will be? It'll go way down. Food will become affordable again if we have great battery technology. In other words, see, I'm trying to give you examples of this. Transportation will become dirt cheap because almost all the transportation on the roads is going to be electric vehicles and electric trucks because of the better battery technology. So then it's a question of what's the cost of the kilowatt hours to push the truck down the road with the load of the food, delivering it to the grocery store, etc. When that cost plummets because power prices plummet, then all your food gets cheaper. See, so this has massive implications. All right, so back to this team from Shanghai. This battery breakthrough is not yet fully ready for commercial rollout, of course. This is just being demonstrated in a laboratory. And another problem is the electrolyte. It's highly corrosive. Yeah, and it's probably because there's a bunch of acid in there. I would imagine it's probably like hydrochloric acid or nitric acid or some other very strong acid that they have in there. So if the battery is punctured, let's say you're in an accident on the road and you have one of these batteries in your car, and the battery gets punctured, whereas with a lithium battery, the lithium catches on fire and burns for hours and nobody can put out the fire, not even the firefighters. Well, with the sodium-sulfur chemistry, the battery gets punctured, a bunch of toxic acid leaks out all over the road, and it starts burning holes in the pavement and releasing horrifically bad acid fumes that will destroy people's lungs if they breathe those in. Yeah, like nitric acid in the air. You don't want to breathe that in. It'll just completely destroy your lungs. So that's going to present new challenges to first responders and firefighters who previously had to worry about, the Tesla vehicle on fire forever. Now they got to worry about, attack of the acid batteries and the, the nitric acid gas cloud that's wafting over the fire truck. You see what I mean? So now it's a different challenge, still dangerous in certain ways, but not on fire. Acid instead, acid. It's just no fun. I mean, I work with acid all the time in my lab because we use nitric acid. Oh, by the way, this research was published in the journal Nature. Okay, so this isn't just somebody's press release. This is actually a scientific study published in Nature. But, I work around acid quite a bit. Nitric acid is highly, highly corrosive, that even having vials of nitric acid sitting around, not even 100% nitric acid, even just 10% nitric acid or 20%, those vials, the fumes coming off of them will rust everything that's metal nearby, including the autosampler robot. So we destroyed an autosampler robot a few years ago just with the nitric acid fumes, because that's the robot that was handling the nitric acid food sample vials. And the robot arm, it moves this, it's an uptake probe that pumps liquid into the ICP-MS. It moves it around, and it's got this kind of, what's the best way to describe it? Like a screw-shaped rod, like a rod with a screw. It's like a giant screw rod that the robotic arm moves up and down. As you rotate this rod, the arm scoots horizontally. That screw rod, even though it was coated with Teflon, which has all these, fluorine compounds in it and everything's supposed to resist corrosion, that thing rusted out. And then I opened up the autosampler robot, and all the electronics were rusted. I was like, my God, how is this thing even functioning? Everything inside was rusted. On the circuit boards, everything. It was the microchips, and they all had oxidation on them. Like, wow, that's amazing. So, and then if you get it on your skin, of course, burns a hole in your skin. If you get it on your clothes, burns a hole in your clothes. That's why my clothes have all these holes in them. To this day, I'm still wearing them. I don't care. You know how I am with shoes or shirts or whatever. I'll just wear it until every last shred of cloth is gone. But if you're wondering why I have holes in my shirts, it's because of nitric acid. So, you're supposed to wear the lab coat. Yeah, well, I know, but sometimes I don't want to put it on. I just go in there and I just use whatever shirt I have on, and if I get splashed with acid, then goodbye shirt. But I do wear safety glasses, by the way, because I don't, like, I can handle losing a shirt, but not losing an eye. You see what I mean? So I'm always wearing the safety goggles, or visors, whatever they're called. Okay, anyway, back to the battery technology. So this new science, it will take several years for this to be fully commercialized. And in the meantime, there may be other chemistries that are commercialized that actually work a lot better. Whatever this donut lab has come up with, they claim it doesn't use lithium. But as I said the other day, I talked to a top-level battery scientist face-to-face in my lab who was visiting our lab to assist with some method validation on a new ion chromatography glyphosate method. And he happened to be a scientist, a brilliant man, by the way, who worked with Samsung and worked on battery tech for, 15 years. So I posed the question to him, hey, do you believe this Donut Lab claim that they've got this battery technology that doesn't use lithium at all, but somehow is a solid state battery, so there's no liquid electrolyte, and it achieves 400 watt hours per kilogram with support of 100,000 discharge cycles, discharge and recharge, obviously. And this guy said, no, it's not possible. In his experience, you can't do it without lithium. Not possible. Again, we're talking about a solid state battery with no sloshing, no moving part, no liquid, no brine inside. Solid state battery. Not possible, my guy says. Other people say it is possible, it's going to happen, and that it's already happened, and those batteries are shipping right now. I don't know about you, but I don't believe it. I don't believe it until I see it. Frankly, I don't believe it until I can test it. I was like, give me the battery, or I'll buy it, but ship me the battery, let me test it, and then I'll believe it. Until then, I'm really skeptical. And by the way, what happens if you have a lithium-ion Tesla vehicle colliding with a sodium-sulfur acid battery vehicle? Do you get both fire and acid and toxic acid fumes? Or do they cancel each other out? It's like rock, paper, scissors. Like, my lithium fire burned out your acid. Or the other one, no, my acid melted your lithium. Those are questions that have to be posed because we're talking about public safety here and people driving on the roads. And some of these big trucks that are going to have batteries will have big batteries, like, hundreds of kilograms of batteries, right? So we're talking about huge leakage onto the roads right out in public on the highway if something goes wrong. So we need to think about that. Finally, in the meantime, there's the old just boring sodium-ion battery chemistry, which the Chinese company Ketal is actually going into production to produce that now. And that battery technology is, it's not awesome. It's not sexy. It's got energy storage of under 200 watt hours per kilogram, I believe. So it's nothing, to brag about, but it's cheap. It's cheap and it's reliable. Because even if you can't get lithium reliably because of what's happening in the world, wars, conflict, tariffs, whatever, you can always get sodium. So sodium-ion batteries are going to represent the sort of the boring, reliable, low-cost battery technology. And there's a market for that. There's a big market for that. See, think about this. So Samsung has this new silver carbon anode battery tech that they're going to start producing in 2027. And that's why they had to buy that silver mine in Mexico. And this is part of the reason why silver prices continue to skyrocket over $94 an ounce right now. Because, Samsung's going to use silver in their batteries that are going to kick ass. But the thing about that silver is it's going to be very expensive. And the batteries themselves, like the batteries that go into a car, for a typical vehicle, just the silver alone will add $3,000 to the price of the car. Think about that. And if silver goes to $200 an ounce, which it probably will within the next year or two, then that means the silver in an EV will cost like $6,000. Just the silver. So that's going to add to the price of the EV, big time. Let's say you're going to be paying $50,000 for an electric vehicle. Well, add $6,000. That's $56,000 because of the silver. Well, sodium ion can do that same battery pack for a fraction of that price. It doesn't need any silver at all. Just boring old sodium. It doesn't have the energy density, so your EV won't drive as far, but it'll be cheap and reliable. And that means for the manufacturers of the EVs, they know they can always get the sodium-ion batteries from companies like CATL. That's C-A-T-L. So the sodium-ion is the tech that keeps the car assembly lines running, where you don't have to cancel production because something happened to the lithium supply chain. You see what I mean? Or, something didn't happen to the cobalt supply chain because that's used in lithium battery chemistry, or nickel or copper or whatever. You just need some sodium, a little bit of aluminum, a little bit of copper. You're good. It's reliable. Okay? So sodium is like if you have horses on your farm and you have one horse that's the superstar, the fastest, strongest horse that can jump over everything. Sodium's not that horse. That horse, that might be the Samsung silver battery technology, but sodium-ion is the old reliable horse that just does what you want it to do, a little slower, a little smaller, but it gets it done. You can count on that horse. That's sodium-ion. And there's a place for that. There's a market for that. Low-cost EVs. All right, so that's my analysis of this. We're going to be launching some new websites this year, including websites covering this kind of chemistry and advanced technologies. So watch for announcements on that. Can't wait to bring you that. And I'll keep you posted on all this and the implications for geopolitics, implications for finance, implications for technology, for decentralization, sustainable off-grid living, etc. And remember that you can use all of our AI tools. BrightAnswers.ai is our AI chatbot. Well, it's really a research engine. It's not a chatbot. It's not chatty. It does deep research. And then we've got BrightLearn.ai, which is our book creation engine. It's got a lot of books, 21,000 books that are all free to download and read. And then we've got BrightNews.ai, which is our news aggregation website. So you can check out all those things and enjoy all of our free tools. And thank you for listening. I'm Mike Adams. I'm the AI developer of all those sites, with much more coming. I've got some surprises for you this year. Well, pretty soon, actually. So get ready for that. We're going to have a blast. And maybe we'll have robots this year. Maybe we'll have robots with sodium batteries. Who knows? And if the sodium leaks out all over the floor, we can sprinkle our nachos with it and have a salty meal. I don't know. We'll see what happens. No, just kidding. Thanks for listening. Take care.
Mother Nature provides many botanicals for good health. That's why we're offering you 5 liquid extracts and tinctures that are non-GMO, certified organic, and lab-tested for glyphosate, heavy metals, and microbiology. Only at healthrangerstore.com.